เอาก็ไม่เอาก็ Okay. Today we're talking about the decibel. Did you hear me?
Yes,
Hello, Mr. Smith. Did you hear me?
yes,
Okay, thank you.
Yeah, we can hear you.
Okay. This is the decibel. Okay. Decibel unit is important in amplify measurement. Okay. Decibel is measure of the ratio of one power to another or one voltage to the other. And also it's a current. Okay. Power gain is expressed in the decibel dB. Okay. And you get the two formula. Okay. For power gain, they're using decibel. This is the formula. AP. A means the gain. P means the power. Okay. dB equal 10 times log of AP. And another formula for the voltage gain, AV in dB, 20 log of AV. Okay, 0 dB reference. The maximum gain equal mid-range gain and a sine 0 dB value. Critical frequency. Okay. Also, they get a different name. They can be cut-off frequency. They can be a corner frequency or break frequency. What happened at this frequency? Output power dropped to 1/2. Output power dropped 1/2 of its mid-range. APdB equal minus 3 dB. Okay. Also, at the critical frequency, output voltage 70.7% of its mid-range. Okay. And AV in dB. Okay. They will be equal 20 times log of 0.707 equal minus 3 dB. Okay. And dBm, power measurement, a unit that is often in measure power is dBm. Okay. The term dBm means decibel refer to 1 milliwatt of power. And this is the formula. Okay. To converting, to calculating dBm. Okay. To the milliwatt or watt, whatever. Now, how do we have to learn to understand about decibel? You're not using decibel anyway in your lab book. However, in the company, okay, they get a lab for RF. That means radio frequency. Okay. That's a very, very important lab. If you get a chance to get into RF lab, your job will be very, very stable. The thing is not too many students understand about the dB. What's the difference? In the RF lab, they do any calculation, measure power gain or voltage gain, current gain. They using dB, decibel. However, outside the lab, we don't understand about dB. So that's why they have to converting dB to milliwatt, kilowatt. Okay, that is how come we need to know a dB. Any calculation about the gain of power, gain of the voltage or current in the lab they're using dB. However, outside the lab, they have to be converting into watt, milliwatt, kilowatt. So we can using that. Okay. And the formula converting, okay, dBm to milliwatt, kilowatt. Okay. dBm equal 10 times log of power divided to 1 milliwatt. Now, they get an example. After they measure, they doing in the lab, they get 30 dBm. What we need to know, how many watt equivalent to 30 dBm. Okay, see the solution. 30 dBm equal 10 times log P over 1 milliwatt equal 30. Okay, that is the formula I just showed you. Okay, you see that? That's the formula I just showed you. Okay, and therefore, now you take the log only. Log of P over 1 milliwatt equal 30 divided to 10. You see that? 30 here. Divide to 10. Okay? The thing is you get a 10 right here. Okay? This is 30. Now you take the log P over 1 milliwatt. They will be 30 divided to 10. You get number 3. Okay? Anti-log. You don't want log anymore. So you take P over 1 milliwatt equal 10 to the power 3 equal 1,000. Therefore, P equal 1 milliwatt times 1,000. You get 1,000 milliwatt equivalent 1 watt. Okay. Any question regarding into the example number 1? Is it okay? Now, you get another example. They're telling you they want to add 1 dBm to 1 dBm. And you understand, hey, you cannot add dBm to dBm. The problem you have to do, you converting dBm to milliwatt, kilowatt, whatever. Then now you're adding the watt or milliwatt. Then you have to go back to the dBm. You see how they working. Okay? First thing you see, dBm equal 10 times. That is the formula. And that equal 1 dBm. Therefore, you don't want to get the 10 times log. You want a log only. Okay? Log equal P1 divide 1 milliwatt equal 1 divide 10. You see that? 1 here, divide to 10 here. Okay? Equal 0.1. Okay? Now you do the same thing, anti-log. P1 over 1 milliwatt, okay, equal, okay, 10 to the power of 0.1. This is the power here, 0.1. Okay, equal 126. Okay, then now you can see you want to calculate the P1 equal 1 milliwatt times 126. You get 126 milliwatt. That is how you convert it. Okay, 1 dBm to milliwatt. You do the same thing for the next one. You get the first one here, and now to do the next one here, they will be the same thing. Okay, you can get the same thing answer. Okay, will be 126 milliwatt. Okay, now you adding both P1 plus P2. You get 2.52 milliwatt. And now you can add it. Okay. Then now you go back into the dBm. Okay. dBm equal 10 times a log of 250. That means total here. Okay. Divide 1 milliwatt. That's given to you. Answer 4.01 dBm. Okay. Note, see what happened here. Cannot add dB watt to dB watt or dB volt to dB volt. Must be 10 to watt or volt. Then add and converting back to dB watt or dB volt. And this is a formula. Okay. To calculate dB watt equal 10 times log of P over 1 watt. Or if you calculate for dB volt, right here. 20 log of volt V over 1 volt. Okay, they're telling you the relation between dBm, okay, and milliwatt. And also, if you want to calculate dB watt, you can using 10 log of P divide 1 watt or dB volt. You can using 20 times log volt over 1 volt. Okay, data sheet say that. Okay. Output amplified 20 dBm. What is output power? Okay, that only telling you in the RF, they calculate a output amplifier 24 dBm. And they want to know what is output power. Okay, you can see the solution here. The formula dBm, you already know with that formula. 10 times log of P over 1 milliwatt. Okay, and that will be equal 24. Okay, so now you only take a log. Then you take 24 divide 10. You get 2.4. Okay, and now you say anti-log. That means you want P over 1 milliwatt equal 10 to the power 2.4 here. You get to 51.2. Therefore, P will be equal 1 milliwatt times 251.2. The answer will be here. 251.2 milliwatt. Okay, that means for 24 dBm, you can get same thing, but in milliwatt is 251.2. Note anti-log is the base 10 raised to dB over 10 power. Okay. Okay, relate problem. Now, I get 10 dBm. What is output power? You doing calculation, telling me, is it A or B or C or D? Which one is correct? Go ahead and do it. That means you have to do the same thing. dBm equal 10 times log of P over 1 milliwatt equal 10 dBm. Okay, so now I don't want, I take a log only. Okay, so they will be log of P over 1 milliwatt equal 10 divided 10 equal 1. Now anti-lock. Okay. That means P over 1 milliwatt equal, let's see, 1 you see the same thing here. Okay. So 2.4 that means equal 10 power of 1 equal 10. So P equal 10 power of 10. Is it 1,000? 10 times 10 equal 100. Hundred milliwatt. How come I didn't see any right? Okay, let's see. dBm 10 times log P over 1 milliwatt. That equals 10 dBm here. Okay, if you get the log only, P over 1 milliwatt equal 10 divided to 10, you get 1. Okay, so P over 1 milliwatt equal 10. Okay, power of 1. That means 10. Okay, and equal 10, P equal 1 milliwatt. That's wrong right here. Okay, 1 milliwatt times 10 equal 10 milliwatt. So the answer will be A, correct. Okay, any question about this calculation? Okay, no question. Now, go to another thing. Cascaded amplifier. That means you get one amplifier, second amplifier. Okay? Normally, AV equal AV1 time AV2. Okay? That will be telling you if you get the gain here, equal 2. Gain here equal 3. Okay? The total gain will be 2 times 3 equal 6. Okay? However, if you're working on dB, they differ. This is the formula. That means AV1 adding to AV2, not multiply. Okay? Impedance matching on resistor should be the same. RG, that means you get an input resistance. Okay? R in, R out, or whatever. RG equal R in equal R out, RL equal R. On resistor be the same. Impedance R in microwave system 50 ohm. Impedance R in TV 75 ohm. Coax cable. Or 300 ohm for twin lead. Impedance R in telephone system is 600 ohm. Okay? Now, at high per frequency for microwave, the dB watt is the usually until unit yield, where the reference at 0 dB watt equal 1 watt, dB volt equal 1 volt. This formula we already get from the last page. Okay? Example, for the amplified cell, you get 2 input watt, output 200 watt. This is the amplifier. Okay? Power gain 10 times log 200 watt divide 2 watt. You get, okay, 53 dBm. Okay? That's the power gain. Okay? You take the output divide input 20 dB. That's the power gain. Okay? However, if you want the power gain on the output, you take 10 log of 200 watt. That means Pout. Divide 1 milliwatt, you get 53 dBm. Okay? Output power dB watt equal 10 times log of 200 watt divide 1 watt, and that given you 23 dB watt. Okay? The input power, you already know, power in equal V square divide R. Power out, output power equal V out square divide R. That's the formula we normally using, okay, in electronics. Review, okay. An amplifier had an input 3 milliwatt, 3 millivolt, output 5 volt. What is the gain in decibel? Okay, answer will be here. Now, solution. See how come we get it? V in equal 3 millivolt. Okay, V out 5 volt. So the gain AV equal V out divide V in 5 volt divide 0.003 volt. You have to using the same unit. You can take the 5 volt divide to 3 millivolt. Now they have to be either you're using volt, they both have to be in volt. If you want millivolt, both have to be millivolt. Okay, so they get the answer right here. And now AV in dB equal 20 log of V out. Okay, 20 log of V out divide V in. Okay, 20 log of V out 1666.7. Okay, and you get 64.4 decibel. Okay, and the second one, a filter has a power input 50 millivolt and output 2 milliwatt. Okay, filter has power input 50 milliwatt, output 2 milliwatt. What is the gain or attenuation in decibel? This is the answer. Okay, and this is solution. They're telling you how can they get it. Okay, P in 50 milliwatt, P out 2 milliwatt, AP gain of the power, P out divide to P in. You get 2 milliwatt, divide 50 milliwatt, you get 0.04. Okay, now AP in dB will be 10 times log P out over P in. Okay, ten times log, okay, of, let's see, of 0.4. You get 13.98 decibel. Okay, so number 3, a power amplifier with 40 dB gain. At output power 100 watt. What is input power? Solution. AP equal P out over P in. That is the gain of the power. Okay, and they say equal 40 dB. Okay, if P out equal 100 watt, what is P in? Okay, so now you see formula for AP in dB. 10 times log of P out over P in equal 40 dB. Log only equal 40 divided to 10. 10 here. Okay, you get 4. So P out over P in equal 10 to power 4. Okay, you get 10,000. That's how you can get P in. Okay, equal here. Okay, and another one. Okay, and you can do it. Review what is the power level of 0 dBm. Answer will be 1 milliwatt. At the following two power level, you want to add 20 dB watt to 20 dB watt. Again, you cannot add in dB. You have to convert in dB watt to watt or milliwatt. Then you add them up. And after you add them, you have to convert in back a dB watt. That is the way how to do it. Okay. Power amplified at 10 dB gain and the input power is 0.5 watt. What is the power output? Okay. So you have to go through that and do it. An amplified with 20 dB gain had an output of 10 volt. What is the input voltage? Okay. And the question is 27 dBm is equal how many watt? Okay. That means they want you to converting 27 dBm to watt or milliwatt. Remember the formula equal 10 times, right? Log of P over 1 milliwatt. And that will be equal 27. Okay? You don't want 10 log, you want log only. Okay? P over 1 milliwatt equal 27 divide 10. 2.7. Now anti-log P over 1 milliwatt equal 10 power 2.7. Okay? And then finally, you can calculate the P equal 1 milliwatt times whatever 10 power 2.7. Okay? Two stages at a voltage gain. Okay? 100, 200, the total decibel voltage gain A. Okay? You understand the voltage gain Okay, 100 to 100. Okay, the gain will be 100 times to 100. However, decibel gain, then you have to add it. Okay, that we already telling you. Adding following 0 dB volt plus 0 dB volt. Again, you cannot adding dB to dB. You have to convert it to millivolt. Okay, and you can adding millivolt. Then you have to converting back to dB volt. Okay, add the following power. Same thing. Now that looks like more easy. 20 dB watt to 20 dB watt. Again, you cannot adding dB volt to dB volt or dB watt to dB watt. What you have to do, you have to converting dB watt to watt, milliwatt or kilowatt. Then you can adding watt. Okay, then you must to converting back into dB watt. Okay, for the circuit show, output equal. Okay, I'm telling you. Okay, this is a 10 dB, 10 dB, 10 dB gain. Okay, and for the circuit show, output equal. You get 10 dB and they drop 3 dB. Okay, then going here, they also gain 10 dB and they drop 3 dB. Up to this point, you gain 10 dB. What output supposed to be? Okay, you can try to do that. Now, so
Hey, Mr.
this,
Pham, go back to that last one. Explain that again.
what?
Go back to that last one.
This one?
Yeah. So you're saying each one of them they lose 3 dB.
Yeah, this is a losing.
So you got 10 dB, then you lose 3 dB, then you got 10 dB, and you lose 3 dB.
Right.
So that's wait a minute. 7, 14.
Then you drop 3 dB 7, gain to 10 dB 17, right? And you
Okay.
drop 3, 14 dB. Okay. Then you gain 10 dB. Okay. I don't know. You try it. Okay. The thing is, I supposed to talking about differential amplifier. However, the student in the class, I saw they doing the lab one around close to 20 students, and now just not enough a half of the students in the class. How can they understand? Okay, coming week, I will be trying to see who not get into the Zoom. Okay, so they can better quit the program. Okay, the thing is they cannot get through it. You don't learn a lecture, how can you know what to do? Okay. So, any question to me? Any question? Nothing?
No, no, thank you.
Okay, so good night, everyone. Okay, have a good weekend. We'll see you on Monday.
Thank you. See you Monday.
Yeah, bye bye.